Okay, let's go through the first few steps of this lab. By the way, I apologize, I'm getting over a cold, so I sound a little rough. We'll start first by opening a new document here, new map document. Okay. I have already connected my Chapter 12 data, but over here we'll go ahead and open it up. I have it under my E drive, Fall 2019, and Shillito datasets, and we have our, as it says in the book, the Mahone raster geodatabase with lakes. Okay, so the first thing we're going to do is make sure our extensions are enabled, and we do that by going to Customize, clicking on Extensions, and ensuring that what we need is enabled. And here he requests that we have Spatial Analyst enabled, which it already is. So I'm going to go ahead and close that. The next thing he wants us to do is add the NLCD Mahone layer to the table of contents. So what I do is I just find it over here, I click on it, drag it over, drop it, and there we go. So the next step is setting environments. This is something you actually had to do back in Chapter 9, and you're doing it again here, and you'll continue to do it throughout any lab that uses rasters. Because what happens with environments is that we're going to be processing a lot of different stages of data, and it saves it instead of having to go in and go through these multiple steps where you save it somewhere in your catalog. This just tells you exactly where it goes each time. So this is one of the reasons why it's super important to do it. Oh, whoops, sorry. Geoprocessing. My computer's a little slow too. Environments. And here we're going to be checking the workspace. The workspace is what we're setting to make sure that what we save goes to the right place. So here you can see it's defaulted to something on my C drive. So I want to change it to where I actually have my data right now, which is in my E drive. So you see here I just have Shillito datasets Chapter 12. I'm going to hit add. So that's current workspace. That just means where it's pulling the data from. And my Scratch workspace, which is where it saves all the temporary data or the in-between files. I'm going to set it as the exact same thing. And you'll typically do that with all of your raster data lab work. And the next thing we're going to do is set the coordinates. This is also something very important. For here, we click on this little caret next to things input, and we'll have it processed as same as layers NLCD Mahone. That means that everything we process will automatically be converted into this so that there's no conversion issues. So this is all he wants for this lab, so we'll click OK. So the first question in the lab is, how are the major roads in the county being modeled with raster data? I know I have it phrased a little differently in the lab questions. That was so I could create a drop-down menu for it. I do think that this question, as it is reads in the book, is slightly confusing, because you might be going like, how are major roads? I don't know. What he's trying to get at is that the roads look like lines, but they're actually pixels. So even though these roads look like they're lines, they're actually, if you were to zoom in, they would be squares. They would be pixels or rasters or cells, however you want to phrase it. So that's what is meant by question 1. So the next thing we want to do, because I'm just going to go over the first few questions in the lab because it sounded like that's where you may be getting a little hung up. The next question is, how many grid cells does this data set contain? So in order to find that out, we right-click on the layer, and we open up the properties. And right here under source, we can see columns and rows, 1593, 866. So to get the total number of cells, we would just multiply those two numbers together. And then for question 12.3, how many square meters does this grid cover? We look down at cell size. Cell size also means raster size or pixel size, which is the smallest unit of measurement that we're using in this lab as it is. So here we have 30 by 30. So we would multiply those two together for 900 is the amount of square meters in this. So we click OK. And I'll just go question 12.4 since I feel like maybe that also is not as clear as it should be. To get to that, figure that out, we're going to right click on the layer again, this time go to the attribute table. And in the attribute table, we can see that, as I kind of talked about in my lecture, they're much smaller than, well, we'll just, there, oops, that got really big. The attribute tables by themselves look much smaller than they do when we're dealing with vector data. But in fact, there's actually a lot more data in there because there's a lot more math that's being done. So in this table, we have 15 fields. And as you'll find out just in the next step in the lab, these values actually correspond to different land type values that are on page 295 of the textbook. And the counts here are actually how many cells represent each of these land type values and for these zones. So that's it for now. I'll leave it there. Hopefully that helps you out a little bit, and we will keep working on this and see if we can make it all make sense. Okay.